Hi, I'm Zach from Turk Banner Singapore. Today, the purpose of the video is to show how you are going to get your process data out from your sensor that feeds it into a module, whether it's Turk or otherwise, and into your PLC/PC. So right now, I have it connected to my PC, and it's the same process that you will go through, except that on your PLC you will have to do a bit more configuration. So over here I know my IP address for my Turk T-band module. I'm going to key it in, and it's 192.168.1.2. One of the good things about the Turk module is that it has a built-in web server, easy for parameterization of your IO-Link master, and good for changing the settings as well as doing testing on your new IO-Link sensor. Okay, so today we are going to show you what the process data structure looks like and how to get it into your PC or PLC. Right now over here I have shown you this mapping profile of this particular pressure sensor. So the pressure sensor will show you a switching output 1 to a fault indicator as well as the process value. All of this will be mapped into a 16-bit word. So you can see that the offset of 1 will actually be a flag for the switching output 1, flag for output 2, and a flag for the fault indicator. The process value itself is scaled differently using different profiles. So some of them will have 16-bit resolution, 14-bit resolution, and this one is a 13-bit resolution process data. So particularly for this guy, right now I have him set to a bar, okay? And currently both of the outputs are actually on normally close. None of them are being triggered because none of their set points are being hit. So both outputs will be on. If I turn it off right now to normally open, you'll see that one of them turns off. Okay, I'm gonna set it in back to normally close so that it's easier for us to decipher what the bits are when we draw our 16-bit value and we want to process it further. Okay, so now I'm just going to go into my documentation to show you how this guy feeds his data into him, and then for this guy's memory registers, how am I going to access it. Okay, so this guy, the pressure differential sensor, is actually connected to my second port over here. Now my port 2, you can see on my device mapping over here, the memory map, the first data word will be at register 18, and I'm going to be using Modbus POL, and I've connected it via Modbus TCP to this particular node, so 1.2, if you can see. Alright, let me move it up. So it's successfully connected, you see, polling at a rate of 1 per second. I'm going to read my definitions, and you can see that my address right now is on 10. I will have a particular word over here. I'm going to change the format to a binary number, that way we can see it more clearly. Okay, so what we do with this particular one, this particular piece of binary data, is we have to process it. If you take a look at my slower screen, so output 1 is mapped to this particular bit, output 2 on this bit, a fault indicator will be on this bit. So I'm just going to take the first 13 bits and then shift it. Now I'm going to bring up my calculator. Okay, so 0, 1, 0, 0, 1, 0, I'm going to shift it 3 bits. 0, 0, 1, 0, 1, 0 0, and these last few bits, I'm not gonna bother with it because it keeps changing. So now, if we, oh sorry, I think you didn't see right just now because of my camera. Okay, so this is basically what it looks like in the program. I mean, sorry, the calculator. Okay, the decimal value of this particular reading right now will be 1284 minus the last 3 bits. Okay, and if I take a look at my device and I look inside the process data, do you see a familiar number? 1287, 1284. So that is how the process value is actually deciphered from your full 16-bit your 16-bit word. Okay, so I hope this was nice and simple video. If there's any other questions, please leave them in the comments below. I would love to hear from you. Cheers. It's Zach from Third Banner. Bye.